Good morning. Hope you can see my screen. So, can anyone confirm?
Yes, sir.
Yes, sir. It's visible.
Um, we were talking about the regression. So, last class we had talked about the correlation and the regression. So, we had talked about, so basically, as you remember, we talked about the correlation coefficient R, right? So, in terms of, say, two variable R, we got correlation coefficient as Rxy, which gives you the idea of that given that two variable x and y are there and how this variable x or y are connected to each other. So if the x is increasing, then y can be increasing. That could be a positive correlation. It could be the other way that if x is increasing, y is decreasing. That could be the possible way, or could be there is no connection between the r, x, and y. So that could be an uncorrelated concept. That could be three possible options. So this could be 0 to 1, and this could be 0 to minus 1, and this could be 0. Three cases we can think of in terms of the correlation and the correlation coefficient. But thing was that RxY give you the direction of the connections between the two variables x and y, but it does not give you the idea that how this variable are connected to each other, right? So given that a value of x, say x some number of 50, say sales y is a profit. So given that say x is 50 unit, can you estimate the what is the value of y, or probably y is some value, say given that I had say a profit of say 70 lakhs or something. So can you estimate what is the corresponding sales? That is not possible to find out in terms of the correlation coefficients. So for that, of course, you need a model between this value x and y. Of course, the model can be a linear model, it can be simple model, it can be complex model. Of course, the one single variable does not depend on a single input variable. It may be multiple variables also, but for our sake of simplicity, we are assuming that okay, one variable is depending on only one variable. So basically, x has a kind of one-to-one relationship between y, right? So if we know the x, we can find out the y. If we know why there is a y, I can find out the x. So there is no other variables. That's why we talked about the simple regression model. And in the simple regression model, of course, there could be linear model, that there could be non-linear model. Linear model, of course, it will give you a linear straight lines kind of things. It will give non-linear models. Of course, it will go for the non-linearity and give you some kind of other types of equations. But again, for sake of simplicity, we think of there is a simple linear model. So we are talking about. Right? So simple linear regression models, you are thinking about this particular a case where you got only one unknown variable and one unknown variable say y, one known variable say x, and of course the things can be different way. So x or both x and y can be dependent to each other. And on the basis of that, we are expecting one linear model that is a kind of linear straight line, and we, in normal sense we give like this kind of equation, and we assume that okay, this is the kind of assumed value of y given that x is there. There could be error there or residue there. On the basis of that particular residue, we can reduce the or we can minimize that particular residue for the all the points possible there, and from there we can estimate our equation. So how this equation get connected to that particular whatever equation I'm going to write in terms of the straight line, that is a part of discussion which we will discuss during our last part of our discussion, that is the estimation theory. We will do the direct the detailed derivations, and little bit I'll show the derivations about all these things, how these equations will generate this whatever equation I'm going to write. So we'll discuss about that later. So we are trying to keep this regression, this part of discussions a little bit simple, and more we'll discuss. Of course, more parameters will more complicated parameters or the probably the useful parameters will come during the estimation theory part. Initially, we are going to talk about the basics of the regression and basics of the regression equation. So after say a lot of calculations, lot of derivations, we found out there could be two equations can be possible. That is regression equations, two equations. That is one is y on x and one is x on y. So these are the kind of estimate equations. So you say for the variable y, variable y depends on x, then the regression equation of of y on x, basically y based on x. So basically, in short form, we generally write as a y on x. That is generally given by y minus y bar b y x minus x bar. Right. Of course, you can understand this x bar and y bar. These are the mean of x and y respectively. And this byx, this is regression coefficient of y on x. Right? So these are the two things. Given that in this particular equation, y minus y bar b yx x minus x bar y, this particular y, the first y, this is a kind of unknown quantity. This x is, of course, initially it is unknown quantity when you are writing in terms of difference. Y is equal to some constant plus x, like this equation. But of course, given that, I mean, assumption is that given that in this particular equation, I can, this x is a unknown quantity for me. Like this y is unknown for me, this x is known for me. So basically, suppose if in a set of numbers, if I know the sales values and if I want to estimate on the basis of the sales, so this x would be the sales and this y would be the profit, right? Y is the unknown quantity, y is depends on x basically. That's why it is called y on x. Y is dependent variable on the basis of x variable. So that's why this is the equation. Now, unknown quantity here, so here is x by y bar. Of course, we know how to calculate, but we do not know how to calculate this regression coefficient of y on x. So this regression coefficient in generally is given by byx is given by covariance of x comma y by sigma x square. In correlation coefficient, it was only sigma x. Here it is sigma x square. Right. So this is the regression coefficients given that y on x. Right. So this is the equation. Next is, of course, if this is the equation, one equation is there, there would be other equation where x would be the unknown quantity, y would be the dependent variable. Of course, the other way also it is there. So if the regression equation is equation of x on y, if it is there, the equation would be x minus x bar be xy y minus y bar. Again, saying x and x bar and y bar are the mean, and this time the regression coefficient looks like bxy. So bxy is given by covariance of x comma y sigma y square. So this is a regression equation of x on y. Okay. These are the two equations are there. Of course, from these two equations, again, this is in this particular equations. Now you know the as if you know the y and y bar values, and you are trying to estimate the x values in this particular case. These are the two equations. Of course, these equations, if you draw, it would be somewhere something like this. It could be something like this. So basically, Of course, this byx and bxy, whatever you see, those are the basically nothing but the slopes of this particular lines. And if you simply write examine these two equations, that is, I'm just writing y minus y bar byx x minus x bar and x minus x bar bxy y minus y bar. Assume the both the cases that the slopes are zero. Say, okay. So basically, if the slopes are zero, that means that y would be y is equal to y bar. That means the one line corresponding to y to the power y bar is equal to this line, and x is equal to bxy is equal to 0. If it's equal to x bar, this particular line would be 0, right? So basically, the point where it will be connected, it will be x bar comma y bar. Same also on go there. So basically, any point, basically these two equations connect or this kind of cross, that is nothing but the x bar y bar, the mean basically of this. So typically, if you solve these two equations, basically if you solve these two equations, whatever number, whatever equations you are supposed to get, that number is nothing but the x bar and the y bar of the particular case, right? And of course, if byx and bxy are is equal to 0, let's understand what is the meaning of this. Of course, if you confirm this equation, you can see byx and bxy are 0. That means, of course, the sigma square cannot be 0, the denominator cannot be 0. So that means that covariance x comma y has to be 0, right? So byx or bxy, if it is 0, that means the covariance of x comma y are 0. That means they both will be the perpendicular to each other, right? So other way you can write bxy covariance xy is equal to 0. That means that rxy also 0. Of course, if you remember, the equation of the rxy was covariance of x comma y by sigma x into sigma y. So if we can keep this, that means that if covariance xy is equal to 0, that means that rxy also 0. Basically, that kind of time that would be things would be uncorrelated. There will be only one connections between these two cases, that would be the x bar and the y bar. So basically, if you and also understand that if these two lines are there in this particular part, if the two lines are there, that the angles between these two lines, because those are the slopes, and if you come from that constant concept of tan theta, the angle between these two lines are basically nothing but the your correlation coefficients. Now, one more things also you can find out in we can write this bxy and byx in terms of the r value also. So that is, suppose if the byx can be given by the covariance of x comma y by sigma x square. So if I just multiply sigma y and like this, if I can write, so basically I am multiplying and dividing the sigma y together, and I am just giving this part. So basically, this option is nothing but your rxy, right? So we can write rxy sigma y by sigma x. So byx can be written by this equation. So rxy multiplied by sigma y by sigma x. Similarly, if you do the same process, bxy can be written as rxy multiplied by sigma x by sigma y. So of course, the regression coefficients are coming from the correlation coefficients with the some permutations of the standard deviations. So basically, if I multiply this sigma yx and byx and bxy, that means that is nothing but rxy sigma y by sigma x multiplied by rxy sigma x by sigma y. So basically, it will become the rxy whole square. So if you multiply these two slopes, that will be give the squares of this sigma x rxy whole square. So basically, rxy would be plus minus of square root of byx multiplied by bxy. Of course, the plus minus is important here because r can take values from -1 to +1. But the thing is that if you see this is a square root value, That means that if the bxy is negative, then byx has to be negative, or the xy is positive, the byx has to be positive. Otherwise, it will become a imaginary values, right? So if byx is negative, then bxy is also be negative. If the yx is positive, then bxy is xy has to be positive, right? So otherwise, so if the sense, it will be a negative number, right? So that will be not possible. Like in terms of this, if we do the square root, it will be imaginary line. In our normal statistics scenario, we generally do not get as a imaginary kind of numbers in that part. So this is the numbers we generally get. So this is the more or less basic theory about the regressions and regression lines. So let's see few examples in terms of this, how we can solve the regression and regression lines. So first I'll give a simple, and eventually we'll go to the practical scenario. So first case, say find the regression equation of x on y. So always, whenever you are doing the problem on regressions, first identify what equation you are going for. That means what is the dependency, what is the independency. For this case, of course, this case it is a x on y from the following. So this is a kind of a basic case. If you have this kind of data, so suppose summation x is given by 24, summation y is given by 44, summation x square is given by 164, summation y square is given by 574, summation xy is given by 306, and finally the number of observation is given by 4. So if this is the numbers are given, of course I need to find out the equation, and second is that find the estimate value of x y is equal to 6. Of course, there is a lot of story maybe there, like what is x, what is y, and how we get these numbers. But let's understand how the things can be calculated. Later we can understand the stories. So first thing first, that I need to estimate that which equation I should go for, given that this particular equation is asking for the x on y, right? We are asking for the x on y. That means that I have to go for the second equation on the basis of x is here the independent variable, and x is here the dependent variable, and y is the independent variable. So I have to go for the equation x minus x bar p x y xy y minus y bar y is the dependent, x is the independent variable. So this is the equation I need to find out. Of course, from there, what are the parameters I need to find out to make this equation? I need to find out the x bar, I need to find out the y bar, and I need to find out the b xy. So let's find out the x bar first. As per my formula, summation I1 to n of xi, that is given. So 24 by 4, that is 6. Y bar, that is again same, 1 by n summation yi is given, that is 44 by 4, that is 11. Next is the bxy I have to calculate. What is bxy? Covariance of x comma y by sigma y square. Whatever it is end, it has to come down below. So first I have to find out the, so basically the kind of calculations are less in terms of the correlation because I did not to actually touch the sigma x square. So extra information is given actually there. So suppose if I just want to find out the covariance of x comma y, this gives me summation. So basically the formula is again, let me write down the formula. So 1 by n summation xy minus x bar multiplied by y bar, right? So it will be 1 by 4 multiplied by 306 minus 6 into 11. So if we simplify this, it will become a, so like if I just simplify, I think it will become as a 10.5. So this is the covariance. And finally, I need the sigma y square. So let's find out the sigma y square. 1 by n summation y square minus y bar whole square. Sorry. So it will be 574 by 4 minus 11 whole square. So it will become 22.5. So eventually, so bxy can be find out by 10.5 by 22.5, that is 0.467. Now all the parameters are here with me, so let's put these numbers into the equation. X minus 6, x minus x bar, 0.467 y minus y bar. So this is the equation. So of course, if you simplify this, it will become x is equal to 0.467 y my plus, I guess, plus 0.86 or something. So this is the equation. This equation is called the regression equation on x on y. So basically, this is the regression equation. Now, of course, given that, okay, I need to estimate the x, given that given y is equal to 6, estimate the x. So if you just put the y is equal to 6 in this equation, you are supposed to get the x value. Then one simple options that, of course, step number 1, you need to find out which equation you are supposed to go for. Then write down the equation. Of course, x bar y bar is the common parameter you need to calculate. Then find out which parameter you need to calculate, bxy or byx, and then you could, find out the required parameters and you put in the equation, and you are supposed to get the equation. And from there, if you need to estimate something, you can find out in terms of the x and y. In terms of the, if you put the x value, then you can get the y. If you find out get the y values, you can get the x. Like second type of options, type of problem would be that we are supposed to get the numbers like in terms of x and y, right? So let's do a problem like that. Yes, so this is the problem. Let me write down the story so you will understand better, like how the examples are comes into the picture. So the owner of a small shop is hopeful that his sales are rising significantly. So rising significantly. So the trend treating the sales of for previous 6 weeks uh, as rising trend. The record shows in table. So I'll just write the table in the next page, and then estimate the sales of seventh week. So basically, you got the sales for the 6 weeks, right? You got the sales of the sales. So basically, owner is basically assuming that okay, his sales are rising significantly. So first, it is a kind of an assumption. That's why this things goes to the estimation part. So so basically on the basis of the particular assumption, she is taking the 6 weeks data. So 6 weeks you got the on the first week how much sales has happened, on the second week how much sales has happened. Like on this case, you got the 6 weeks data, and on the basis of the 6 weeks data, we need to find out on the 7 weeks data, and from that we can estimate that okay, this is a rising significantly, or it is a growth, or it is not a growth. Either way, it can be possible that we can understand that his estimate or his assumption is correct or not, and then we can actually finds out using the simple linear regression that okay, his assumptions are correct or not, and how much he is supposed to sales on the seventh week. So basically, this is the story. I mean, you might have seen this kind of problem. Engineering comes a lot in the practical scenario. What are the numbers are given? So we're taking these weeks as numbers here, weeks as a variable x, sales as y. So first week, second week, third, fourth, fifth, and sixth. Of course, these numbers are given to us. First week we got 2.69, some unit, 2.62, 2.80, 2.7, 2.75, and 6 is 2.81. These are numbers are given. So on the basis of that, we have assumed that weeks as x and sales as y. That means that here x is a dependent variable, y is the independent variable. Sorry, x is the independent variable, y is the dependent variable. So we are supposed to use this equation y minus y bar byx x minus x bar. So basically, as x is x, and of course we are going to estimate on the seventh week. That means that x is equal to 7. We are going to put into this particular equation. So we are going to find out this. So since we have to find out x bar and y bar, obviously I have to add these numbers. So better I need to remove this equation because I need these numbers to be there. And as we have shown that, okay, let me write down here. Say that we are going to use y minus y bar byx x minus x bar. So what are the things I need? I need x bar, y bar, and the covariance of x comma y divided by sigma x square. Right? So these things are required. Sigma x square, x bar y bar need means that I need a summation x, summation y. Sigma x square need means that 1 by n summation, x square is there. So I need to find out the x square values. And covariance xy need, that means I need to get the value of xy. So these are the numbers I need. Okay. So of course, so x are the weeks numbers. So that on the basis of that, I need to find out the x square. That is 1, 4, 9, 16, 25, and 64. Of course, I am not taking care of the change of scale and change of origin in this particular scenario, because of course it is possible, but we are not showing that here. Straightforward on the basis of the numbers we are doing the calculation. Of course, x multiplied by y, so numbers would be 2.69 to 5.24 8.40. Please check the numbers when you will do by yourself. 13.75 and 16.86. So these are numbers we got. So if I add this is nothing but summation x. I'm going to get summation x is 21. This would be summation of y for the y bar I need. So it will be 16.37. This is summation of x square, that is 91. And last was summation of xy. I'll get this as a 57.74, I guess. Okay. So now, of course, one by one, I need to calculate. Um, that is, x bar would be 21 by 6. 6 observations are there. So 3.5. Y bar 16.37 by 6. So it will be 2.73. Then it would be the covariance part. Covariance x comma y would be 1 by n summation xy minus x bar y bar. So it will be 57.74 by 6 minus 3.5, 2.73. So maybe something like 0.065 will be there. And sigma x square would be 1 by n summation of x square minus x bar whole square. That would be 91 by 6 minus of 3.5 whole square. Eventually it should come something like 2.91. So byx could be 0.065 by 2.91. So something like this will come. Now if you just put into the equation, that is y minus how much? 2.73 minus 4.22 x minus 3.5. Right. So this is the equation for that regression. So now on the 7th week, if I need to find out that x is equal to 7, so if you put this number, it will come as something nearby 2.81, which is not much significant because it is basically the same numbers of the 6th week, whatever we had. On the basis of that, we are getting the almost similar kind of number into this particular case. So the assumption was that there is, it is a significant rise is happening. So of course, rise is happening. There is no dip is there. I mean, there is no loss is happening, but it is not a significant rise, as we can say that okay, the 6th week and the 7th week is giving me the almost similar kind of a numbers in the number in the terms of the sales, right? So this is a kind of a estimation patterns we can find out. The last problem in this particular case, what we will do is that suppose we got the two equations, how we can deal with this kind of problem. So the line of regression concerning two variables x and y be given by one is y minus 32 minus x and x is equal to 14 minus 0.25y. So obtain values of mean and the correlation coefficients. Right? So two equations are given. Did not tell which equation is what. These are the two equations. Which one is x on y and which one is y on x? This is not given. We have to assume. Second is that from this equation they are asking that okay, what are the means you can find out and what is the correlation coefficient. Of course, our basic equations always start with our basic equations: y minus y bar b yx x minus x bar and x minus x bar b x y minus y bar. Of course, these two equations from there, if you understand that x bar and y bar is a constant value, and if you multiply with the correlation coefficient, that also constant value. So basically, these two equations basically you can find out y is equal to a plus bx. Like that way, we can write down these two equations. Now, this is a two ways to solve this. So two type of problems are there. Of course, if you see the equations are like something y is equal to something minus something and x is equal to something minus something, whatever the equations are given here, if you see in that particular pattern that by default almost you can understand that left hand side whatever equations, what are the variables we generally take, that is the dependence variable and y is the x is the independence for this particular case. So we can take this equation here actually, y is equal to 32 minus x, and the other way the x is equal to something is there, so that means that x is here dependent, y is the independent, so we can take this equation here 13 minus 0.25 y. Okay. These two things we can easily we can assume in terms of the two sets of assumptions, right? So that is possible. But if some problem, it is written like x plus y is equal to something, or say x minus y, y minus x something, or something 0.5 y minus 3.2 x is equal to something. If that kind of equations you find out where it is not explicitly given that okay, we can understand that okay, this equations is belong to this particular class, then the type of problems we need to the attack is that we need to assume that okay, one equation we assume that this is the y on x, this is the x on y, and the next process would be the same, like how the way I'm going to do that. That is, we need to find out the bxy and byx, and we multiply and we find out that r value. If the r value is because r square value, and from the r square value we find out the r value. If the, as we know, the r values limit is -1 to +1, if that follows, that means our assumption was correct. That why this is y on x and this is x on y. If that does not follow, that means that r value is going beyond its limit. That means that our assumption was incorrect. You switch that your assumption, whatever you have chosen, that y on x, make it as x on y, and whatever is x on y, make it as y on x, and do the same process again. So for this case, what will happen is that suppose this is the equation, as I assume that okay, this is the two equations are there. Of course, we may say that okay, we can find out the constant value, we can accumulate the constant value, but there will be too many unknown variables are there. So one simple thing is that if you multiply this equation, it will be byx into x minus some constant. But this coefficient of the x, that will be fixed all point of time, byx multiplied by x. So basically, we can compare these two equations in terms of the coefficient of the x, that is here it should be byx. So in these cases it should be byx should be not +1, it is -1, right? Because by default 32 plus x, I mean if you write in terms of this, it should be like some plus x minus plus something. So if we compare these two equations, we can find out this is 32. Basically I can write like 32 plus of -1 into x. So from there I can find out byx is equal to -1. Similarly, if I compare these two equations, bxy multiplied by y, so basically I can write this again, same thing, 13 plus -20.25 into y. That means that the xy is here -0.25. Of course, as I told you previously also, if the byx is minus, then the other numbers has to be minus, because at the end of the day, when you are you are multiplying these two numbers, it is going to give you the r square value. R square value cannot be negative in any case. So that is a kind of a checkpoint. So if you are getting this as a negative, it has to be negative. If you are getting this as a positive, either number is a positive, other number has to be the positive number. So that's how basically you can find out the bxy and byx. And as we have found out that if r square is equal to multiplication of byx and bxy, so if I just multiply these two numbers, this should be 0.25. So r square is 0.25. So r would be plus minus 0.5. Do not forget the plus minus because r can be either side. It can be plus 0.5, it can be minus 0.5. Either cases, it can be possible. In this particular cases, even if if we take the business scenario cases also, this plus minus cannot go. It can be either scenario because the directions. This depends on the directions. How this your x and y are basically correlated. That is positively correlated. It can be negatively correlated also. So we got the correlation coefficients. The last option is that we need to find out the mean of the two cases. Of course, again you can say we can put this bxy and byx value and find out the mean. But this best option is that, as again I told, that the where these two equations coincide, that point are nothing but the your mean values. So if simply we just solve this equation, y is equal to 32 minus x and x is equal to 13 by 0.25y by our simplistic process, just by eliminating the point. Like if I just put the x value here, like y is equal to 32 minus 13 plus 0.25, sorry, 0.25y, like this process, if we just find out by this way, that would be the, that is, if we whatever solving points are we are getting, that is nothing but the y, your x bar 1 y bar values. So it would be, I guess, 10, that's 22, 22 minus 19. So I think it will come as 25.3 or something. And if you put the value in terms of this equation, that should be 6.7. So these numbers are nothing but your mean values of this equation. So that's how basically you can tackle this kind of problems in terms of the regression parameters. So this is that much differentiated kind of problem we can face in terms of regressions. Now, of course, as we have get some kind of hint that some estimations, some assumptions, that means some hypothesis scenarios are coming into the picture. Of course, this has some kind of connections between the already we have seen the forecasting scenario, but of course there are some kind of connections between to the hypothesis theory and the estimations theory and this particular part. So we are stopping this discussion of the regression into this particular part. So we will start again from here. Like we have assumed that this is the equation we are supposed to get in terms of the regression lines, linear regression lines. But of course, there are more things are there when which we will discuss during our estimation theory classes. So from this, we are kind of end of our deterministic kind of scenario. So here the kind of deterministic statistics and everything are we are done with that particular part. And if you have observed properly that we have already jumped into our inferential statistics. So we have done with our descriptive statistics that we have done actually before the correlation itself, and then we have already slowly have jumped into the inferential statistics. Now, of course, since in this particular scenario the numbers are quite deterministic, so okay, this is the, if x is this number, y has to be this particular number, right? But that does not happens in our practical scenario, right? So of course it is a kind of a probabilistic scenario that okay, this particular value may give this particular number. So that is the always the scenario is that, right? So since this application of the probability is obviously inevitable in this particular scenario. So how the statistics is getting connected with the probability. Of course, as you can see in a practical scenario that in terms of say machine learning algorithms, of course, as I was talking about the multiple non-linear situations of the regression lines, that one variable can depend on the x1, x2, say xn in number of parameters. And of course, this particular parameter has not like a fully connected kind of scenario. So x1 parameter can be say 0.2 percentage, this can be a 0.4 percentage or something, some kind of cases it would be say 30% or something like that. So this kind of numbers we can assume, we can some kind of weightage we can assume on the set of each and every parameters, which makes them kind of a probabilistic scenario. So of course that sense of the probability, sense of the probabilistic number wise issues will come into the statistics, which leads us to the something is called a random variable. So maybe you have, if you are into the electronics or some communication classes kind of area, so you might have heard this particular word a lot of times, this random variables. So this random variables are kind of a random experiment. These things comes into the picture, so that gives you kind of favorable cases, or the kind of I mean, out of whole cases, there could be some few favorable cases. So that is the basically the basis of the probability. So what we will do, we'll talk little bit about the basic of the probability. Then we will see the application of the probability into the statistics. Basically, that is what we are going to do in this particular section. So, in terms of the probability, basic probability is that, of course, we'll take generally. I guess assume that we already heard about the Venn diagrams. So that is a diagram we generally explain all our probabilistic theories. So basically, if in the terms of that, in any kind of experiment, so basically we talk about this as a random experiment. What is random? That is that any experiment which is gives you some kind of output which is equally probable. Basically, if I suppose if you're throwing a coin, it is equally probable if it is unbiased coin. If it is highly probable that either you can get a head or you can get a tail. So basically, you can assume that okay, either I know that okay the possible outcomes, but I don't know exactly which particular outcome is going to come. So that is a called random experiment. Random experiment. Under the random experiments, whatever the possible outcomes are there, basically all possible outcomes are basically are the total number of possibilities. Basically, you can see as a S, that is the total number of possibilities. So if you're throwing a coin, that means that total possibility will be either you can get a head or you can get a tail. If you're throwing a dice, so you can get any number between 1 to 6, 1, 2, 3, 4, 5, 6, any number you can get. Like this, basically, the random experiments we do. Now, under this random experiment, something is called event we defined. Right? This event we defined, say event is say A. A is an event. That event can be defined as say you get a head. So when you are tossing a coin, you are getting a head. That is can be a event. A can be a getting one on the dice. That could be an event. Getting even number on dice, that could be a event. So depending on the basis of the event, we can find out number of favorable outcomes on the basis of this total number of possibilities. So of course, given that you are getting a head or tail, so of course this is your total event. Under this total events, your favorable events getting a head would be 1, right? So basically the probability of A in that particular scenario is basically is defined as the denominator is uh, total number of possibilities, and on top it will be the possibility that satisfies the condition. Possibility that satisfies the condition. right? So this is the two case, that's how basically we generally define the probability. So for this case, getting a head out of say out of two possible options, you are defining only one option, that is the probability is half. Getting one out of, so total number of possibilities is six for a dice. You should get a six numbers out of getting a one would be one out of six. Out of six again, if you getting a even numbers, that will on the dice, that will be 2 4 6, three numbers will be there. So 3 by 6, that is half, it will be there. Like that process, you generally calculate the probabilities. Now this is the event, of course, and if we define the events in the terms of the Venn diagram, so this is the S, this is the S, right? So total options, and here you are defining a event A, here you are defining the event B. So of course the probability of A is given by this particular area, probability of B is given by this particular area, and of course there will be some blank space where the probability are not defined, or other events are not defined. Of course that particular has also this blank space also should have a probability, right? Of course the definition of any event does not mean that I am defining everything in this particular scenario. Okay, so this is the A event A and B. Of course, A has, if this is the scenario of the A, the rest of the non-A part is called generally called the A complement, right? So not A part, it's called the A complement. A complement could be within the B also, like the blank space plus the B is the A complement part. Now, few formulas are there. So basically, let's just write one by one. So in simple scenario, say one is P A union B, or some books they write as a P A plus B. So it would be P A plus P minus P A intersection B. Why it is minus? So suppose if I just two overlapping cases, if I can assume. So basically, if you're adding this A as well as B, so basically this intersection area is basically is called the A intersection B. So this is the intersection B area. So that's why, since you are taking this two times, so we are just minusing the one part. So this is the intersection B. So P intersection B is equal to, also it is written as P of AB. Same again, to few books follow A intersection B, few books follow in terms of A dot B, or simply P of AB, like this. Now this P of AB has two options. That is, in that case, if one scenario is that there is no connection between these two, there is no overlapping into this part, so P intersection P or AB is equal to 0, right? So this particular case is called the mutually exclusive events, right? So this A and B are now mutually exclusive events in the terms of, like, in again simple examples. If you are throwing a coin, getting a probability of getting a head and probability of getting a tails are kind of unique. There is, I mean, either you will get a head or you will get a tail. You are not going to get a head or tail together, right? Probably in same cases for the dice also, probability of getting head is a different probability of, I mean, like 1 2 3 4 5, any number you are going to get, at the same point of time you are not going to get a 3 or 6 together, right? So these cases, these are called the mutually exclusive events, right? Now second case would be if they are overlapping each other, but they are not depend to each other. Okay, if that situations comes, like suppose event A is that I am getting a spam call, and B is getting, say B is it is raining outside, say A is I am getting a spam call, say, and B is raining outside. Typically this two has nothing to do with to each other, right? So but it is possible that during the rain I may get a spam call, that is possible. though it is there, since it has nothing to do with a dependency kind of such a scenario is there, I can write as a P of A multiplied by P of P. Similar cases, if you say I'm throwing two coins and I'm getting a head or tail, one getting a head or head in one particular coin does not affect the getting a tail or head in another coin. That is also possible in this particular cases. So that if that scenario is like something like that, then it is called the ANP are called the ANPR independent event. So this is the independent event. Third type of events are there, which are something like this. Suppose this is the universal set. If I'm drawing a square, that means that this particular square or rectangle is a universal set. That is the S. Say A1, A2, and A3 are there, right? Or so these things are there. Three events are there. A1, A2, and A3 events are there, and of course these events you can see it is mutually exclusive. A1 is happening, then A2 is not happening. When A2 is happening, then A1, A3 not happening, right? So basically already A1, A2 and A3 are mutually exclusive, as well as if you see probability of A1 plus probability of A2 and probability of A3, or if I just do the A1 union A2 union A3, that is giving you the universal set, right? So if that is the scenario, then you can tell that this is also called the collectively exhaustive set. So in this particular scenario, A1, A2, A3 are mutually exclusive as well as collectively exhaustive set. Okay. So many cases you will find in the later part also there are a lot of scenarios coming to the picture where the systems where the events are mutually exclusive as well as the collectively exhaustive. All the cases, if you see any event A, that means that A and A complement are mutually exclusive and collectively exhaustive. If any no other events are there, it is always happens that A and A complement will be mutually exclusive and collectively exhaustive. So basically, the concept is that if that all the variables I'm talking about, A1, A2, A3, if you add those three, that should give you the total set. That is the all possible universal set. That is the case. So that is the meaning of the mutually exclusive and collectively exhaustive systems. So more or less, so we have done two problem definitions. Now, of course, since we have talked about the independent set, given that this is the scenario, and we talked about there is a if it is independent, then this case happens, these things happens. What if it is dependent? So scenario is same, but it is dependent to each other. So one event is depending on the other event. Suppose in terms of say event, there is a two boxes are there, one ball is transferred from say one white ball is transferred from this box to another box, and then I am finding out what is the color of the second ball. Of course, in that particular scenario, that transferred ball color of course depends on the if the output color is the depends on the transferred ball color, right? If that is the case, that kind of cases happens, that means it looks similar, but here it is a dependency is there. Then it is called the dependent scenario. So in this case, if it looks something like this, that means that the event A has already been happened. Now I'm trying to find out the probability of the B. So the statement is that given that the event has happened, given A has happened, and now what is the probability of B? So it has a formula of A intersection B by P of A. Similarly, the opposite way may also happen, that probability, given that the event B has happened, what is the probability A? We need to find out. So that is given by A by B. So it is also given by PA intersection B by P of B. So whatever comes later comes here, right? So again also I can write PAB by PA. This is right, PAB by PB. Correct. So this is a dependent variable. So basically here B is dependent on A. In the next case, A is dependent on B. So of course from these equations I can write PA as PAB as PAB can be written as uh, PB by A multiplied by of PA, or PA by B multiplied by PB. So from there I can write, right? So so this particular is formula is called the theorem of the compound probability. Hmm? Theorem of compound probability. Okay. Of course, like it can keep on going like in terms of like A or B or like this. Okay, anyway. So this is theorem compound probability. Now two more things need to be added, because eventually we understand that at some point of time we are going to talk about the Bayes theorem. So I'll just give you the basics of the Bayes theorem using these concepts. So two events are there, A and B. If we know already this is the A, right? So this is the A. If somebody asks like what is the probability of only A? Only A means of course this particular part, the intersection part, is not I'm talking about, right? So that means that probability of A minus probability of A intersection B, or the PA minus PAB, right? That is the basically part I am talking about. This is a P of only A. So how can I write this P of only A using the B complement? So probably I can write the same expression in terms of in a single line probably. So think about this. If I can write like this or not. P of A intersection of B complement. So B complement means that is the, I mean, including this A intersection B part also, the complement, whole complement part. So basically that means that anything away from this particular line, anything away from this particular line, that is the your B complement. And if you do the A intersections, you can understand that this is basically that it is giving me the A, only a particular part, right? So that's how basically I can write this particular case. So now, if I just write this line, P of A minus PAB gives me P A intersection B complement, or the PAB basically they just remove the intersection part, nothing else. P of A complement, right? So PA can be written as PAB plus PAE complement. So from there I can write like this. Now if I use the theorem of compound probability, it is possible to write P of B multiplied by PA by B, and P of B complement P of A by B complement. Right? So I'm just using a theorem of compound probability. So I'm writing in terms of P of B multiplied by P of A by B complement, and sorry, P of B multiplied by P of A by B, and P of B complement multiplied by P of A B complement, even though B complement. Similarly, P of using the P of only B, so I can write P of only B. Observe the image. So there also I have to just minus the P of B minus P of A intersection B, right? So same way I can write the P of A complement intersection B, that is nothing but the P of only B. Same way, if I just use this same statement, P of B minus P of A intersection B, that is P A intersection B complement. So I'm just writing in terms of the AB format. P of AB is equal to P of A B complement B. So PB is equal to PAB plus PA complement B. Now if I'm using the theorem of compound probability, P of A multiplied by P of B by A plus P of A complement by P of B by E complement. So keep this two formula, because you will see this is the kind of a basis of your PS theorem. So basically I can write in terms of two formula, this P of A and P of B, which are later part we will see that nothing but the theorem of total probability. Basically this is called, some later part will show that this is called the theorem of total probability. So this can be written in terms of a dependence variable dependence. Basically these are this kind of in dependency case you can actually calculate easily, okay, and which is basically nothing but the kind of the scenario you can show that okay, the one case the event is happening and this that is the dependency cases, and the non-dependency as such it is a complement part if it is there. So basically if the this you can say this event A is a kind of a effect, that particular effect is basically on the cause of there, this is okay, this is the cause A of happening, not cause happening, not happening, not that of not cause, that is basically is given by these two equations, right? So these are kind of a basis of the your some basis, of course not this only this, some basis of your Bayes theorem. So basically these are the two theorems you can keep. Okay, so a lot of equations we have done. So now let's do some basic problems in terms of this equations, and eventually we'll go to our traditional probability kind of problems. Few two three examples also give from there also. So let's go for that. So first simple problem. Suppose this is a scenario and this blank space got also probability here. So whatever things are given, P intersection B is given as 0.2, P of only B has given the value of 0.4, and P of this blank space is given as 0.3. What to find out? Find out is P of A intersection B complement. 2 is P of A, and third is need to find out P B of A, right? So what are the things I will? So basically blank space probability is given as a 0.3. P of only B, that means that this without intersection part is given as 0.4, and the intersection part is given as 0.2. So basically what, how can I write the whole universal set? The P of S, which is nothing but 1. So I can write as a P of only A plus P of A intersection B, P of only B plus P of blank space, right? You can write like this way. So P of S already you know, this is a 1. P of only A, which is eventually I need to find out. This is nothing but a P of only A, just I have shown you. So let's keep it as a P of only A. P of only A plus A intersection B already given, that is 0.2. P of only B already given, 0.4. P of then is already given, 0.3. So that means that P of only A is 0.1. That is what the P of A intersection B complement. Right? So I got the P of only A. Then if I need to find out the PA, what should I do? Just I have to add the P of only A plus P of A intersection B, that is 0.1 plus 0.2, that is 0.3. Next, third one is the, I need to find out the PB by A. PB by A, PB by A as a formula, PAB by P of A. Already knows the, the numbers. P of AB is 0.2, P of A is 0.3. So 2 by 3.67 is the answer. So this is a one simple problem. Now let's go for one formula based problem. So say given P of A is 3 by 8, P of B is 5 by 8, and P of A plus B given by 3 by 4, find PB by A and PA by B. And second question is, are A and B independent? So I need to show that it is independent or not. Right? So of course, formula wise, I have to follow this kind of a problems. Straightforward. So already given as P A plus B is given. That is the formula is PA plus PP minus P intersection B or PAP. Right? So whatever things given, I got. This is 3 by 4. This says 3 by 8. This is as a 5 by 8. This has a minus PAB. Right? So PAB has to be, this is a 1 minus 3 by 4. That is 1 by 4. Correct? So now again, straightforward formula. I need to find out PB by A, right? So PB by A, formula wise, PAB by PAB is 1 by 4, as I found out, and PA is 3 by 8, that means 2 by 3. PA by B, I need to find out. PAB by PB, same process, 1 by 4 divided by, now this is 5 by 8, right? 5 by 8, so 2 by 5. So last is that are A and B independent or not? So what is the definition of the independent? It has to be PAB is equal to PA into PB. So the other two sides I need to show that, because already I know that PAB is 1 by 4. Now if I want to multiply PA and PB, that then it should be same as 1 by 4. So if I just multiply this to 15 by 64, which is not same as this number, so that I can write PAB is not equal to PA into PB. That means that these are not independent events, they are dependent events to each other. Last of this set, of course, for that, is some of you have seen this. If you are in computer science background, probably something we have heard. Some formula is called as a DM, that's De Morgan's law. Right? So De Morgan's law, it is also part of the set theory actually. So De Morgan's law states that if A dot B is there, that means that A bar plus B bar, right? And if it is A plus B whole bar, you can write in terms of the A bar or B bar. So these two formula are there. Of course, in terms of probability, if I just write, so first case, of course, if I just write the probability of A B whole, that can be written as P A bar, bar in the terms of the complement, right? Bar and complement same. So second is P A. Either case, if I just write like this, either cases I can write it P of A plus B whole bar, because the whole complement, that means nothing but the 1 minus B A plus B, right? So these are two formula there. So using this formula, this is a small problem. So the problem is that, like I say, if A and B are independent, event does that mean A bar or a complement, what you say, and B bar are also independent event. So we have to prove it obviously. So that means that I need to show that P typically, if it is true, that means that P A bar dot B bar should be P A bar multiplied by P B bar. Then either it is true or it is false. That is our assumption is that initially it is asking that okay, if it is true, then you need to show this basically. So we'll start of course from the left hand side. So that means P A bar dot B bar, right? So I'm going to use this equation, whatever, just last equation what you have used, same as that. That means that it can be written as P A plus P whole bar using the De Morgan's law, and that means nothing but the 1 minus P A plus B, right? So now I know the formula of the P A plus B, so let's put that. A plus B is P A plus P B minus P A intersection B or P A B, whatever. Now just take out from the minus part, minus P A minus P B plus P A B. Now given what is given, A and B are the independent events. A and B are the independent event. That means that this PAB I can write into as a PA into PB. 1 minus PA minus PB, which is as a PA into PB, since A and B are the independent events. Correct? So let's take a little bit algebra. So let's take this as a 1 minus PA, right? Now, if I take a PB common from this case, what will happen? This will become 1 minus PA, right? That means this is 1 minus PA minus 1 minus PB, correct? 1 minus PA means that is a complement, as I told, and that's nothing but the PA bar, and this is PB bar. So that means that this is equal to this. So what we have from there, we have as our to be proven thing has been proven. That means that if the AB are independent, then A bar and the B bar are also independent. You can use this particular problem in terms of that if A and B are independent, then A bar and B are independent or not. If A and B are independent, then A and B bar are independent or not. You can try those combinations also to find out if those combinations are independent or not. Okay. Now this is a kind of a algebraic kind of a probabilistic scenario. Now what about the practical scenario? So let's do a little bit the practical problems. Very basic kind of tossing coin problems. So say two unbiased coin are tossed. What will be the probability of actually one is both heads, one head, one tail. Both tails and fourth be at least one head, right? Very simple standard problem, right? So you got two unbiased coin. Of course, this word unbiased is very important because that gives you the probability. Two unbiased coins are tossed. What is the probability that both are heads, one head and one tail, both tails and at least one head? Of course, I can do this particular problem in two ways. That in a standard procedure, that okay, if there are two heads, two coins has been tossed, then the all possible options would be both would be head, one tail, one head, and both would be tails. Right? And there are one options. Of course, now in this particular case, I say one one is head and one. When both heads are there, of course, one options only one options are there. That is one head. So that could be 1/4. Second case, one head and one tail. I guess in the two situations I can find out that is HD and TH. That is 2/4. That means that 1/2. Third options, both are tails. Of course, one options are available here. So 1/10, it's 1/4. And the fourth option, at least one head. That means that head, tail, and tail head. Three options are there. That's why 3/4. That is one option. The one way we can solve it. But of course, the other way can be solved in the terms of that. Since, as I told, this if the two coins are being tossed, that means that both the coins are kind of independent to each other. So I can take these two problems in terms of that. These both heads are basically can be written as. So suppose this is the head options. So since both are independent, I can write as a multiple. So basically, P of AB is multiply PA into PB. Like the same process I can write. Now I can tell, okay, so now getting a head from one particular coin is half, and similarly the one other point is half. That is 1/4. Like that I can find out. Similarly, one head and one tail. If that is the case, then I can write probability of head multiplied by probability of tail. Plus probability of tails multiplied by probability of head, right? I can write like it also. So like that process also 1/4 plus 1/4, that is 2/4, that is half. Both tail of course same as TT, same. And at least one head, again the same things will come up as a PH, PH plus PH, PT. PT multiplied by PH. So 1/4 plus 1/4 plus 1/4, that is 3 by 4. Same process I can write. So of course, this particular problem has a multiple ways to solve. Of course, why I'm telling this, because this particular concept is important. The independence concept is important, because suppose it is initially was an unbiased one. What if this is a biased one? Then what will happen? So again, the same problem is there. So the two biased coins are tossed. For each coin, probability of getting head is, say, p. P can be any number, 0.1, 0.2, 0.3, 0.9, whatever. It can be any number, not 0.5. No, it can be 0.5 also. Then probability of obtaining both heads, one head, one tail, both tail, and fourth is the at least one head. Same problems are same, just probability are different. At least one head. Right? Same problems, but now it is given that is a biased one. So there is no 0.5 situations is there, and you are getting at least head is p. Now what will be these values? The thing is that we have to use the two options here, two concepts here. One is the mutually exclusive, that is getting a head in a one coin does not connect to the getting another head or tail in another coin. There is a mutually exclusive situation. Second option is that it is a collectively exhaustive system. That means that probability of getting head and probability of getting tail is always 1, because there are only two options are there. I mean, there is no other third options are there. So that means that if the probability of getting head is p, then probability of getting tail would be 1 minus p. That is coming from the collectively exhaustive situation. Okay. So basically, this situation is actually mutually exclusive as well as the collectively exhaustive situation. Then only you can write this scenario. So now for the both of the case, both heads are there. That means that P of HH, since mutually exclusive and independent events, of course, independent event also, that PH into H. So it can be written as a P into P, that is P square. Right? Second case, one head, one tail. Right? So that means that P of HT plus P of TH. So that means the P of H multiplied by P of T plus P of T multiplied by P of H. So P multiplied by 1 minus P plus 1 minus P multiplied by P. Simplify. So whatever number you are going to get. Similarly, two tails. That means P of TT. That is nothing but P of T multiplied by P of T. That is 1 minus P multiplied by 1 minus P. Right. Last one, at least one head. Right. That means P of HH plus P of HT plus P of TH. Right. So simply if I write P of H into P of H, P of H into P of T, P of T multiplied by P of H. So P square P into 1 minus P plus 1 minus P multiplied by P. So I think if you simplify this, it should come something like 2P minus P square. So this is the concept. So like not all the problems are like a simple same way you can solve it. Of course, find out the situations which particular cases gives you that different scenario. In this particular case, as I told you, that this case kind of is situations that your events are mutually exclusive. That's why P and T, and collectively exhaustive. That's why PH plus PT should be is equal to 1. That is for sure. And third one is these are independent events uh, that it is not dependent. Sorry, it is independent event that is P of HT can be written as a P of H into P of T. So like this, we do the basic problems. So we'll do the few more basic problems. Of course, the basic foundations in terms of the base theorems, I'll just keep core till that particular part and show the basis of the like given that dependency kind of problems also we are going to do. So I think let's take a break now and we'll come back after 15 minutes and we'll do the basic problems of the dependent variables and then we'll go to the eventually go to the base theorem and then finally we'll see that okay how the statistics, this probability is connected to the statistics.